Let's talk about something that sounds, kind of dry and technical, data storage. But here's the thing, it is the secret engine behind every single app you use, and more often than you'd think, it's the real reason they break.
Seriously, think about it for a second. The last time a service you count on just vanished. The real culprit probably wasn't some flashy new feature with a bug. Nope, it was almost certainly a failure deep down in its data storage.
So, what's the deal? Why is data storage this secret villain in the background? Well, as we're about to see, the way most of us have been taught to think about the problem is the problem.
Okay, let's get right into it. For years, probably decades, the big debate among engineers has always been framed as this super simple binary choice. You know the one, right? Are you on Team SQL with its super structured, reliable world and its rigid schema? Think of that like a really strict blueprint for your data. Or are you on Team NoSQL, the flexible, super scalable option? Here's the problem. Forcing that choice completely misses the point. It's a massive oversimplification, and it holds us back from building systems that can actually withstand the real world. We need a better way to think about this.
And here it is. This is the new mental model, storage as a spectrum. So instead of one simple choice, we need to evaluate our options along a few different axes of trade-offs. It's not about picking A or B. It's about finding the perfect spot on the dial. Let me break it down. First up, we've got the trade-off between speed and durability. Do you need absolutely blazing fast access to your data, or do you need an ironclad guarantee that once something is written, it is never, ever lost? You can't always have both at max level. Pushing one usually means pulling back on the other.
This is a classic. Is it more important that every single user, everywhere in the world, sees the exact same up-to-the-millisecond data? That's consistency. Or is it more important that your app is always online, always responsive, even if it means some data might be a tiny bit out of sync for a second? That's availability. You usually can't have perfect 100% of both.
And of course, there's the money. You can absolutely build an incredibly reliable system, a digital fortress, but it's going to cost you. Or you can build something cheaper that's, well, maybe a little less dependable. And this isn't pocket change we're talking about. Storage can easily eat up 30 to 40% of a system's entire infrastructure budget. That's a huge deal. So getting this trade-off right is crucial.
So now that we have this new spectrum model in our heads, let's take a little tour and see how it actually applies to the three main kinds of data that pretty much every system has to deal with. Okay, first we've got structured data. This is your classic, predictable stuff that fits so neatly into tables with rows and columns. Think financial records, user accounts, things like inventory. The relationships between the data points are everything. But it has an Achilles heel, a huge challenge, changing that structure down the road.
So let's say your team wants to add a new feature. You need a new column in your users table to store some preferences. You write this line of code. It looks completely harmless, right? I mean, it's so simple, so tiny. What could possibly go wrong?
Famous last words. On a tiny little database, sure, it's instant. But on a table with 1 billion users, that simple change can lock up the entire table for hours. It can take your whole service offline. And just like that, a tiny code change becomes a massive, all-hands-on-deck production incident. Okay, now let's pivot to the other end of the spectrum, unstructured data. We're talking about all the photos, videos, and audio files that we're constantly creating. The amount of this stuff is just staggering. In fact, this kind of data often grows 3 times faster than all your structured data combined. So you can imagine just trying to manage the cost and performance of it is a huge deal.
So how do designers handle that without going totally broke? Well, this is a perfect example of the spectrum in action. They tier the data. A photo you just uploaded today, that's hot data. It lives on expensive, super fast storage, so you can get to it instantly. But that photo from 5 years ago, that's cold. It gets moved to incredibly cheap, but much slower, archival storage. This is that cost versus performance trade-off playing out in real time.
All right, finally, let's talk about the data that lives right in the messy middle, semi-structured data. The most common format you'll bump into is called JSON, and it promises this amazing flexibility, which sounds awesome, right? But that flexibility, it can be a really dangerous trap.
I love this quote because it just hits the nail on the head. There's this myth of schemaless data, that you don't have to worry about structure anymore. But that's not true. The structure is absolutely still there. It's just hidden inside your application's code now, instead of being clearly defined in the database. And honestly, that can be way harder to manage.
So when should you use this stuff? Well, it's perfect for things that are genuinely different from user to user, like personal settings for an app. But it is an absolute nightmare for data you need to run reports on, like order data.
Just imagine trying to calculate your total company sales by digging into millions and millions of individual little JSON blobs. It's a recipe for a slow, painful, and super inefficient system.
So, what does all this really mean? How do we take all these lessons and actually start building better, more resilient systems? Well, it all comes down to a fundamental shift in how we look at the problem.
So here it is. This is your new playbook. First, just stop asking SQL or NoSQL. It's a dead end. Start thinking in spectrums. Figure out what kind of data you have and then make a deliberate, intentional choice about where it belongs on the spectrums of cost, performance, and consistency. Because here's the secret. Great engineering isn't about avoiding compromises, it's about making them intelligently.
And that leaves us with one last thought. The next time you open an app on your phone, any app, just take a second to think about it. Is it prioritizing lightning speed over perfect up-to-the-second consistency? How is it possibly managing the cost of all those photos and videos? Now that you have the framework, you can start to see these hidden decisions, these trade-offs, absolutely everywhere.